Alright, hi year 11, it's Mr. Lim here again, and this is our video on percentage concentrations for aqueous solutions. So let's get started. Okay, we're going to be doing weight for weight, volume for volume, and weight for volume in various contexts, so we'll see how we go. Alright, so what you should know about concentration for weight, volume for weight for volume is effectively that weight for weight means the mass of something divided by the mass of a solute divided by the mass of the solution times 100. So it's effectively the percentage of the solution that is the solute. Same thing for volume, but instead of it being mass, it's being how many mils per mils of the solution. And weight for volume is the mass divided by the volume. Okay, right, so let's have a look at this. So here are some examples. 12 mils of ethanol is dissolved in 40 mils of water. Determine the percentage volume for volume. Okay, so remember it is the percentage volume for volume is equal to the volume of solute over the volume of solution times 100. Okay, so this one you got to read a little bit carefully because this one here, 12 mils of ethanol, that's easy enough. But the volume of solution is 52 mils. Where did I get this number? Because it's from 40 and 12 added together makes 52 mils of solution. Okay, so not just the 40 that it was dissolved in, and therefore that will be 23%. Okay, so times 100, 23.08%. Okay, so you've got to remember you're looking for the volume of the solution, not just what you dissolved it in. Okay, let's have another one. Calculate the mass. So calculate the mass of a solution that is required to have 40 grams of magnesium carbonate if the solution is 12% weight for weight mixture of magnesium carbonate. Okay, so the equation is percentage weight for weight is equal to the mass of solute over the mass of solution times 100. Okay, so what does that mean? So I would say, okay, then, I want to have 40 grams of magnesium carbonate. So that's my mass of solute. That's how much I want, all right? It's asking me for the mass of solution. Okay, the mass of the solution, which means that I'm unsure of the mass of the solution, times 100. And I know that it's a 12% weight for weight mixture of magnesium carbonate. So I need to rearrange this equation. So the mass of solution will be equal to 40 over 12 times 100. Okay, if you're unsure about how to rearrange that equation, you can come see me. We'll go talk about that one later on. So 40 divided by 12 times 100 is effectively 333.3 grams of solution is required so that you can get 40 grams of the magnesium carbonate in it. Okay? So it's just about using that equation and then rearranging it. All right, let's have another look. Another question. Okay, so calculate the volume of solution that is required to have 2.4 moles of nitrate ions from a solution which is 14% weight for volume calcium nitrate. Okay, so this one here, what we're going to do is we're going to look at the moles of the nitrate ions and we're going to think about, okay, well, I need to get the mass of the calcium nitrate. So how do I turn this 2.4 moles of nitrate ions into mass of calcium nitrate? Okay, so we need 2.4 moles of nitrate ions, so that's easy enough. So the number of moles of nitrate ions required is equal to 2.4 moles. That's just from the question. Okay, so we've got our solution concentration in calcium nitrate, so I need to work out how many moles of calcium nitrate do I require. And the number of moles of calcium nitrate from the nitrate ions is going to be half, because there are 2 nitrate ions for every calcium nitrate. So to make 2.4 moles of nitrate ions, I only need 1.2 moles of calcium nitrate. Okay, because every mole of calcium nitrate will produce 2 moles of nitrate ions. So that's the number of moles that I need. I can work out the mass of the vat calcium nitrate, which will be equal to N times M, which is equal to 1.2 times the molar mass of calcium nitrate, which will happen to be, what's that? 164.1 times that by 1.2 is 196.92 grams. That's how many grams I need. All right, so the percentage weight for volume equation would be the mass of the solute, which is what we're looking for, over the volume of solution times 100. Okay, I need 196.92 grams. I don't know how much I'm going to need to get there, but I know that it is 14%, and I know that I got to times that by 100 over there. So I rearrange this equation so that the volume of the solution is equal to 196.92 over 14 times 100. That seems like it's going to be a very big number. Divided by 14 times 100. 1,406.6. And what's the unit here going to be? It's going to be in mils. Okay, so we're going to keep this in mils because the weight per volume is generally the mass in grams in the volume of mils, 100 mils generally. All right, so that's 1,406.6 mils are required. Right, another one, weight for volume here. Calculate the volume of 13% weight for volume hydrochloric acid that is required to create 200 mils of carbon dioxide at 25 degrees Celsius and 102 kilopascals when reacted with excess solid calcium carbonate. So the reaction for this one is HCl plus calcium carbonate goes to H2O plus CaCl2 plus CO2. Now you need two of those. All right, and that's a balanced equation. We can work out the number of moles of carbon dioxide that is formed, or that is required, or actually, yeah, that is formed, which is equal to, N is equal to PV over RT, which happens to be pressure 102 times volume 0.2, because that's in liters, R 8.314 times 25 degrees, which is 298.15. Okay, what's that going to be? 102 times 0.2 divided by bracket 8.314 times 298.15, close brackets, is going to be 8.230 times 10 to the negative 3 moles. Okay, so that's the number of moles of carbon dioxide that I need, right? So therefore, the number of moles of hydrochloric acid that I need is equal to the number of moles of carbon dioxide times 2 on 1, which happens to be 0.016 mole. Okay, so that's how much I need. So let's work out the mass of that. The mass of that HCl, so that's going to be the N times M, which happens to be 0.016 times the molar mass of hydrochloric acid, which is 36.458 times that moles, which is 0.583 grams. Okay, and then I'm going to work out the volume. The volume of the solution, which will be equal to the mass of HCl required over the concentration in percentage times 100, which is the rearrangement of the equation. So that's going to be mass, that's that one there, divided by the concentration, which is 13 times 100, divided by 13 times 100. That's 4.487 mils. Okay, that's how you would do that one there. Right, last one. Okay, so using it in a bit of stoichiometry. So let's have a look. So calculate the weight for weight of a suspension of magnesium hydroxide if 70 grams of the suspension requires 15 mils of 0.1 ethanoic acid to completely react with all of the magnesium hydroxide. So the reaction is ethanoic acid plus magnesium hydroxide. Depending on when you're watching this, you may or may not know how to write out these equations, but if you don't, that's okay. Just look here, this is the equation. So this is going to be magnesium ethanoate. Oops. 2 plus H2O. I'm going to balance that equation. 2 here, 2 here. Okay, that looks about right. Okay, so calculate the percentage weight for suspension. If 70 grams of suspension requires 15 mils of ethanoic acid. Okay, so we can work out the number of moles of ethanoic acid, which is equal to CV, which is equal to 0.1 times 0.015, which happens to be 1.5 times 10 to the negative 3 moles. Okay, so now I have that, I can work out the number of moles of magnesium hydroxide that it reacted with. Okay, so that reacted with the number of moles of calcium hydroxide times 1 on 2. Okay, so divide that by 2 is 7.5 times 10 to the negative 4 mole. Okay, that's the number of moles of magnesium hydroxide I need. So if I have that, I can get the mass of the magnesium hydroxide, which is equal to N times M, which is equal to 7.5 times 10 to the negative 4 times the molar mass of magnesium hydroxide, which is 58.326. So I'm going to take my 7.5 times e to the negative 4, times it by that, and I'm going to get 0.0437 grams. That's how many grams I need. All right, so that's how many grams I need to react with the ethanoic acid. So then I'm going to take that mass, well, I guess we're going to think about the percentage. So percentage weight for weight will be equal to the mass of the solute over the mass of the solution times 100. Okay, so that will be what? 0.0437 over the 70 times 100, which is going to be a small number, which is 0.0624%. Okay, so not a very large amount. All right, so those are the examples that we're going to do for percentage. We're going to practice this in class, so we'll see how we go. And then if you have any questions, ask in class. Adios.